Next thing we are going to do is we're going to do the product rule for radicals. Is that there? This is not terribly difficult, believe it or not. This is awesome. This is an easy thing that we're going to do today. I have the nth root of A times the nth root of B. All right. And when I multiply these together, okay, I will end up with the nth root of A times B, okay? Now I want to point something out in this. In order to multiply them, they have to have the same index. You see why it's important for you guys to know the language, right? All right, so notice that they're both an n, correct? Since they are both an n, they're allowed to be underneath the same radical, okay? That's key to this one. If this is a 2 and that's a 3, we gotta change them, or we just say we can't do this one. All right, so we can change it like we did before, change it to exponents, find an LCD, and then move it all the way over and call it good and put them underneath one. All right, but these two have to be the same. I don't care what's underneath. I can multiply anything together. Cats and dogs make hogs for all I care. Okay, genetic engineering. All right, n and n. The only thing that's important is that the indices need to be the same. Has everybody got that? Okay. Only the indices need to be the same. All right. The radicands do not. I don't care about the radicands. All right. You ready to try this? It is super easy, guys. Let's try it. I have the square root of 2 times the square root of x. Are the indices the same? Yes?
Mm-hmm.
Smush them. Okay, we're going to smush them together. You've got the square root of 2x. If they are multiplying here, then they will be multiplying on the inside. So I don't really need a dot between them. If you want to put the dot there, you can. But if they're multiplying here, they're multiplying on the inside. Everybody good?
Mm-hmm.
Awesome. All right. What if I give you the square root of 7? I love 7 today, times the square root of 3t. And again, keep asking yourself, are the indices the same? If it's a yes, smush them, okay? Are the indices the same? Yeah. What's my final answer? 21t, because it's 7 times 3 times t. Those are all multipliable. Multiply the numbers together, add the t. All right, what if I give you the cube root of 6m times the cube root of, let's see, 5t squared? What am I going to get you? 1 more time? 30t squared m, or 30mt squared, however it is you want to write it. I don't really care the order. All right, it's perfectly fine. And the reason we can multiply them and put them underneath the same radical is because they have the same index. Exactly. All right. Now, let's kick it up a little bit from here, okay? Let's try the 4th root of 25 times the 4th root of 125. Now, before you spaz, okay, do they have the same index?
Mm-hmm.
Yes. Whatever you do, as you've been seeing so far, do not, and I repeat, do not try. Does everybody agree with that's all we've been doing, right? Unless there's leftovers at the very end. So if we want to simplify this thing even further, break down the 25, break down the 125, okay? Do not multiply that out. That is just a waste of time, okay? 25 is what times what?
5 times.
And 125 is?
5 to the third.
5 times 5 times 5. You're saying 25 times 5, right?
Mhm.
So remember, 125 is a cube. 5 times 5 times 5. So that's just one number. You gotta be really familiar with it. Do I have 4 of a kind?
Yep.
Yeah, I have one set of these. So I'm left with 5 times the 4th root of 5. Now, how did I know that I was going to have one left over? How many 5s did I have underneath? 5 5s? So that's 5 to the 5th. So I knew I wasn't done because that inside power would be larger than the index. Everybody cool with that problem?
Mhm.
All right. Let's try another one. What if I gave you the cube root of 2x times the cube root of 4x squared? Now, these numbers are small enough that you can multiply them together, right? They're harmless when we do that. So 4 times 2 is 8. I'm okay with 8. I'm not cool with 125 times 25. All right, that's just a large number. So I can multiply these together. 4 times 2 is 8. X times x squared is x cubed. Now, if you didn't do it in between a step, that's quite okay. What is the cube root of 8? 2. What's the cube root of x cubed? X is 3 divided by 3 is 1, right? Notice that everybody is gone. The radical goes away because I took everything out. Don't leave me with like the square root of 2x. We popped all that stuff out, right? All right, how are we doing?
Good.
We're okay. Let's kick it up. Let's do some. Let's do a little bit of polynomials in here. I have the cube root of y minus 2 times the cube root of y minus 2. What would I have as a final answer? Be very careful. First off, I'm going to smush them together like I always say, right? Smush them first, right? All right. Now, I understand the reason why you guys would want to foil this, but do not. Okay? How many y minus 2's are underneath? 2. So we would just write this as y minus 2 squared. Do not foil, okay? Just leave it as this. Oh, is everybody with me? Okay? Do not do any more, all right? This is great. There's reasons for it, and we're going to see later on in this chapter as to why we want to leave it this way, okay? Never ever foil underneath the radical right now. Foil. Can I go any further with this problem?
No.
Why?
No, because the index is higher than x.
Right. The index is bigger than the power on the inside, or vice versa. The power on the inside is smaller than the index, right? So we know that we're done. Okay? Now, just when you thought, remember that? Okay. Just when you thought that this was pretty nice and pretty easy, you know how much we love factoring, right?
Absolutely.
We totally love it. What if I give you the square root of x squared minus 5x plus 6 times the square root of x squared minus 7x plus 10? Alright, what did you factor the first one into?
X minus 3 and x minus 2.
Oh.
Oh.
X minus 3, x minus 2, or x minus 6, x plus 1?
X.
No.
Two.
3 and 2.
X minus 3, x minus 2?
Yeah.
Yo. I don't want to give you a negative 6. Sweet. Alright. The second one, what did you factor this into?
X minus 2, x minus 2.
X minus 5,
X minus 2.
x minus 2. Alright, once you've got them factored, it is easier this way. Get the hard stuff done. A lot of people still hate factoring. Do the factoring, get it over with. Now it's time to smush, okay? And when we smush these all together, I have, and I'm just gonna keep it in the order it came in, x minus 3, yeah, like I said that. X minus 2, x minus 5, x minus 2. Do I have 2 of a kind? Yeah, these two guys, I have 2 of. My index says anything that has a group of 2 I can pull out, right? So I'm gonna take out both of these, that's one set. And by the way, if it's in parentheses on the inside, it's in parentheses on the outside, okay? And I'm left with underneath x minus 3 times x minus 5. Leave it here, do not FOIL.
No, what was that really bad? Because I got x minus 6 and x minus 1. What would you do?
If you did x minus 6 and x minus 1, yeah, let me just FOIL this for you. You have x squared minus 6x minus 1x, and I screwed this all up, plus 6. I did 4 FILE. Alright, but I still get x squared minus 7x plus 6 at 5x. Okay, so this is one of the trickier ones no matter what, because there are 2 possible answers it looks like, right? 6 is equal to 1 times 6, 2 times 3. This can give me plus or minus 5. This one also can give me plus or minus 5. This gives me plus or minus 7. And again, I'm just like, if you add them together, you get 7. If you subtract them, both are negative, you get negative 7. If I add these, I get a 5. If I subtract these, I will get a 1. So plus or minus 1. They look like possibles, right? But when you want to, and again, this is positive 6 with a negative 5. If I use the 6 and the 1, a negative 6 and a positive 1 will give you a negative 5, but when you multiply these 2 guys together, I will get a negative 6. So I can't use that one. And if they were both negative, a negative 6 and a negative 1 will not give me a negative 5, but it will give me a negative 7. Okay, so either way, I change the signs or whatever, I'm either not getting the bottom number or I'm not getting the top number with the sign correct. Does that make sense?
Yes.
Okay. So one more time, let's go back to this one. If you have parentheses on the inside, you need parentheses on the outside, because what this is saying is all of this times is radical. Do not do this. Do not do x minus 2 times x minus 3, x minus 5, because what it's saying is x minus 2 times all that, instead of this whole thing times that. Does everybody understand that?
Mm-hmm.
Dropping the parentheses is really bad, okay? You change the whole answer to the problem. Everybody cool? That was a lot of talking. All right. Do we want more, or are you guys comfy with this? We're good?
Mm-hmm.
You know what, let's do a little bit more factoring to see how good you really are. All right, let's strip the light right past it here. What if I give you, the square root of 4b squared minus b cubed c squared? All right, just when you thought you knew what you were doing, be very careful on this problem. This is a GCF type problem on here. What is the GCF on the inside? We're just pretending that the radical is not there, everybody, okay? For the time being, radical is not there. So
4b squared.
What is the GCF in here? A 4. They both share a 4, right?
B squared.
And they both have a b squared at least, right? If I factor that out, what am I going to be left with for my first term?
1 minus
1. Then I got the
b
minus
squared.
3.
C squared.
I got 1b left and a c squared, exactly. Okay? So this is all taking place still underneath the radical. I cannot do each term individually underneath, okay? So, take a look at what you factored out. Awesome. This is garbage, okay? You took out everything that you possibly could, and this is now crap. This stays on the inside. What's the square root of 4?
2.
2. What's the square root of b squared?
B.
B. What is left? Your crap. Your leftovers, okay? Be very careful when you have plus or minus only underneath, okay? Then it's a GCF problem.
So you can't take the C out because it was in parentheses.
I can't take a C out also because
There's nothing in common.
It's not in common. And that's a very common thing that students want to do. Oh, I can take out a 4 and a B. Oh, I can take out a 4, a B, and a C. Right? But you can't do it individually. It's got to be all or nothing. You can't just pick and choose where you want to take it out of. Does that make sense?
Yeah.
Okay? When you have something like this, GCF, and then you're working with the GCF only. Is everybody with me?
So it's just anything involving where we need to get the GCF, we can't just take out like this leaf she said it.
Nope.
Okay.
Nope. This is now untouchable. Okay?
Then-
Let's do it again because these are funky and I'm thinking a take-home quiz on them. Alright? Almost the same, but not really. Okay. Check it out, see what you guys are doing. Alright? Follow the procedure from the previous one. Pretty close. Everybody with me so far, what I did on the board? Yes? Okay. Now, one more time. All the stuff that you factored out is the stuff that you can only work with, not the stuff in parentheses anymore. What is the square root of 9?
3.
What's the square root of g squared?
G.
Can I take out this c?
No, leave it there.
No, this is a power of 1. This 1 is less than your index, which is 2, right? This is smaller than that, I can't take the c out. The only way to take a c out is if it was like a 2 or a 4, right? Okay? So, as much as I want to take this c out, this c remains. Is it part of the GCF? Yes. Not everything in the GCF is pull-outable, if that's even a word, okay? So, I am left with the square root of c times 1 minus 3gc. I would leave it like that, but if you want to put it back in, you can. You can write this as c minus 3gc squared. Just understand, resist the urge to not take out the c from the c squared, right? Everybody got me? Everything that was left over was crap. It stays underneath. Yes?
Can you explain this second step again? Just do the differently slowly. I'm just not grasping.
Right here?
Yeah.
Okay. Exactly where though?
Any
Any
of it.
of it?
You go from 1 to 2 and I just completely get lost.
Okay. Hang on one second. Here's what I'm going to do. I'm going to do it again. Okay? So, let's start out really, really small. What do 9 and 27 have in common?
3.
Go higher,
Oh, fine.
right? This is, and I'm just gonna leave it, this is 9GGC, right? Minus 27 has a 9 in it, correct?
Right.
So this is 9 times 3 GGGCC. Okay, if I want to expand it all out. What do they both have in common, in here, and between the first two terms? They
Oh, I
have a-
see, so 9.
So if I pull out a 9, this 9 goes away, right?
Right, and then
Okay.
2 G's.
2 G's, so a G squared,
And
so
then
those 2 G's go away.
And C squared.
I can only pull out 1 C,
Right, so you pull a C from there and a C.
C from here,
Right.
1 from each,
Oh, so it's not squared, it's just 1. Okay.
just 1, because I pulled out 1 C from each. Since all of this is gone, this means that there's a 1 here. Because I took it all out. It's like saying 9G squared C divided by 9G squared C, which is 1, minus any leftovers 3GC. Does that have that all out?
Yes, that helps a lot.
Okay. 9 is 3 times 3, so we can take out a 3. And take out the G.
C is.
C times 1 minus 3GC. Now understand, I made this one up. You're not going to see this one in the book, but you are going to see it on the take-home quiz, because I give some funky stuff like you guys know. All right? When you see 2 terms underneath, it's a GCF. If there's 3 terms, either it's a GCF or it's a factoring problem. Okay, like we did before. How are we doing?
Good.
More understandable? Yes.
Did you have to put the 1 in the second part? With the-
No, you do not, but I left it there to make sure everybody sees that I only took out 1 C, not 2. But no, the 1 doesn't have to be shown unless you want to. I don't really care if the 1 is there or not. All right, are we good? All right, let's take a break.